Hi guys, I'm Eddie. Today we are going to look at paper 2, still on the low-hanging fruits, meaning the easy marks that one can score. In paper 2, here is just an overview of chemistry. There are a number of easy marks you can find in 3 main sections. The first section is on organic, that is question 2, 3 and question 4. The second one is electrochemistry, which is question 8 and 9. Then finally is on fertilizers. Right. The lowest hanging fruit, part 1 of paper 2 is mostly on organic, right? Let's have a look on the questions, right? This is a question which is based on the table, that is naming of the molecules. Let me write it down. This is basically based on this. Let me say you've got our cake, which this cake carries a decoration of 5 decorations, right? This is basically our homologous series, meaning all organic families that one has to know. Fine. C, it means your carboxylic acids. So I'm just trying to write it. Your carboxylic acids, that is carboxylic acids, our carboxylic acids, right? Then we have A representing alkanes, that is alkanes, alkenes, alkynes, alcohols, as well as aldehydes. These are our 5 A's. Then we have our K representing the ketones and E representing the esters. So this is basically all our homologous series, the ones that we have to know. So in each and every situation, you should be in a position to identify each of these families that has been written here. Being in a position to identify each and every single one of them, knowing their functional groups, and also knowing the general formula, drawing the simple structures of each family, then that is going to help you to answer the questions, right? Let's have a look and see what is it that will score if you just know the general things like that, right? Let me go through the question. Here's a table which is given basically on question 2. Write down the letter that represents a compound that has a carbonyl group, right? A letter that represents a carbon that is a carbonyl group. The carbonyl group, that is our functional group. So in this case, if you are to answer your question, that is 2.1.1, you should know these structures. Now, obviously, the answer will be this one that represents our carbonyl group. But if you don't have any idea of these families of esters or these homologous series, then you start to have problems, right? So it means our letter, in simple terms, becomes E. Then, which letter here is an alcohol? It's a very simple term. It's a very simple question where one just needs to identify a family of alcohols from the table. So in this case, alcohols, we know them by having an OH. So in this one, we look all over the table. The letter which is having an OH, that is C. So that is an easy mark which one can score. So our letter becomes C. Then 2.1.3, still, this is a little bit challenging, but the chain isomer, this is not that much challenging, because if one can define what a chain isomer is, we know that isomers, firstly, when you're discussing about isomers, you should know that isomers simply means same molecular formula. Same molecular formula. Right, same molecular formula in this case, if we have got a chain isomer of this one, CH3, CH2, and CH3. So we need to know, yes, this one is having 1, 2, there are 3 carbons there, so 3 plus 1, that gives us 4, and this one is 5. So we want another one which is having 5, another hydrocarbon with 5 carbons. This one is 1, 2, 3, 4, 5. This one also has 1, 2, 3, 4, 5. Then the number of hydrogens here is 3 plus 2 plus 2 plus 2, because we have 3 to give us 6 plus 3, that's 9, plus 3, that will give us 12. Let's have a look at this one. This one is also having 6 here, 7, that becomes 10. This one is having 3, 6, 9, 10. Right, so what are we going to do here? A chain isomer of this one. Fine. Well, you are seeing that we are having a little bit of some challenge, so you leave this one because it's relatively a high order question. Right, let's move to the next question, which we just want to look at easy marks. Right, so I have left that one because it doesn't look like that much easy. Let me have a look on the other part of the question, which is question 2.3. 2.3.1, homologous series, that is identifying the family to which compound E belongs. Compound E belongs. This is compound E. Compound E, if you would know our cake, from our cake, which is our cake, you should know that we have carboxylic acids, we have alcohols, aldehydes, alkenes, alkanes, and alkynes, right? But this one is esters. So if you do know each and every functional group of this one, then it will be easy for you to know that one. So the functional group of this one is this. In this case, this one is an ester. So the homologous series to which E belongs, that is an ester. We are all eating. This is part of our cake, right? 2.3.2, name or formula of the catalyst used in the preparation of compound E, which is this one. We all know that the esterification reaction, it requires sulfuric acid, or you can write it in full since it is saying that is sulfuric acid. You can write name or you can write the formula. Both of them are acceptable, right? IUPAC name of compound E, just naming compounds is something which is relatively easier. So naming esters, it's a little bit easy. We know that the first part of the name comes from A, which is an alcohol, and the second part comes from a carboxylic acid, which is now being changed to anoety, right? We want to name this. Also, given the structure of an ester, you should know that the side which comes from the bridge oxygen, this is our bridge oxygen. You can see a carbon structure, this, that is our carbon chain. But in between these carbons, there's what we call the bridge oxygen. The side which is on this bridge oxygen, that is the side coming from the alcohol, and the other side, which is this side of the carbonyl group, is the side where we get the carboxylic acid, right? So which alcohol is it that is having one carbon? The carbon alcohol with one carbon, we call that one methyl. Fine. And the carboxylic acid with 1, 2, 3 carbons, that is methyl propanoate. That gives us the name of the IUPAC name of compound E, which is our ester. So you should basically see that naming compounds, drawing structures, the key things you should know. You should be in a position to identify families of organic molecules. You should be in a position to draw structures, and you should also be in a position to know the functional groups. Then you name them. If you know this, it means all the low marks, the easy marks, you can easily get them from this one, right? Let's have a look on this one. This is another question on organic. This question is not that much challenging. It just needs definitions, also reading the information that is given. Like for first thing, let's see what define boiling point. Definitions are very critical, and guys, we should not play games when it comes to boiling point, right? Boiling point in simple terms is just the temperature. It should be a temperature point, boiling point, temperature at which vapor pressure is equal to your atmospheric pressure. So there's no shortcuts for definitions. Is equal to atmospheric pressure. Right. So in the graph here, we should be in a position to tell which one is our boiling points. Fine. Let's move on. From curve P, write down a conclusion that can be drawn from the above results. Let's read from here. We are told that we have got alkanes, carboxylic acids, and alcohols. Right. So from there, we should know the knowledge concept which is being tested there. We should know the difference in boiling points between alkanes, carboxylic acids, and alcohols. Right. These ones, the type of forces that you find in alkanes is only the force which we will call weak London forces. The weak London forces. Then in carboxylic acids, we find hydrogen bonds. But this one, it forms twice the strength because it is having two sides of bonding. Then alcohols, they also have the same type of force, which is hydrogen bond. But this one, they have only a single side of bonding, since they only have one OH. Right. Now, so this means this is the weakest type of force, followed by this one, and that one is the strongest. Now, so the one with the highest, which is in this case R, our R, that is the carboxylic acids, then Q, that becomes the alcohols, and P, that becomes the alkanes. Right. For curve P, write down a conclusion that can be drawn from the above results. So our conclusion now is, for similar sized, let me correct this so that I write it neatly. Right. For similar sized molecules, alkanes have the lowest boiling points compared to carboxylic acids and alcohols. Right. That will be our conclusion. These are all simple things. Basically, they're just testing on, do you know the type of intermolecular forces in alkanes, in carboxylic acids, as well as alcohols. So you will be done with your question. Let's have a look on another one. Identify the curve PQR that represents each of the following. We have already identified them. Alkanes is the one which will be having the lowest, so that is going to be your P. That is so easy. Carboxylic acids, they've got the strongest intermolecular forces, so that one is going to be our R. Right. Easy. Let's have a look on another one. Explain answers to question 3.2 by referring to the types of intermolecular forces. You are seeing that we have already addressed it earlier on when we said you should know that carboxylic acids, what type of force is in carboxylic acids? That is hydrogen bonds. Then also in alcohols, we should know that they are hydrogen bonds as well in alcohols, and in alkanes we have London forces. But these carboxylic acids form two sides of bonding. They've got two sides of bonding. So the hydrogen bond that is there is much stronger than the hydrogen bond that you find in alcohols. Right. Let's now answer the question. Referring to type of intermolecular forces present in alkenes, carboxylic acids, and alcohols, these are the types that you have mentioned. Also, the relative strength of these intermolecular forces plus the energy. So this is how you should answer our question. 3.4. Carboxylic acids, they've got hydrogen bonds. Alcohols, they also contain hydrogen bonds. Alkanes, they contain London forces. Right. Then the next point, now we are commenting about the relative strength of these intermolecular forces. Now we are going to say London forces are the weakest. Compared to stronger hydrogen bonds. We are comparing now the strength of the forces. The last part is the energy needed. So less energy is needed in alkanes than in alcohols and acids. Right, we've answered our question. By this one, then we can see that we are done with our question. Let's have a look on another part of the organic chemistry section, which is this one. Right, let's have a look on this one. Right, guys, basically what you have to know is, given a flow diagram, talk to the flow diagram, unpack everything that is there, then you analyze the diagram thoroughly so that before you start to answer any questions, so that when you get into the questions, you have cleared all the obstacles in front of you. Right, in this case, we have got what basically you have to know. We have got three common or major organic reactions, which are addition. Right, the opposite of addition is elimination. Then we have substitution. Right, when you've got substitution, addition, it only happens to molecules that contains a double bond, or molecules with a name that end with an ENE and nothing else. That is the good thing. Right, these molecules, they react to produce molecules with only a single bond. Right, the opposite of addition, that is elimination, where we have saturated molecules reacting to give us unsaturated molecules. Right, substitution reactions, it's saturated molecules reacting still to give us saturated molecules. Then basically this is how you can see whether it's an addition reaction, whether it's an elimination reaction, whether it's a substitution reaction, and this is a guideline on how you identify these main type of reactions. Right, let's have a look again. This one is prop 1 in, meaning its name contains an ENE. That means it's having a double bond. Right, so whatever type of a reaction which this one undergo is an addition reaction. Fine. Then the opposite of that, that is our elimination reaction. So let's have a look. This one is an addition reaction. This one, C, is an addition reaction. This one with an HBr is an addition reaction. Right, let's identify now the reverse of addition reaction, which is elimination. This one is elimination reaction. D is elimination reaction. Right, from there, let's have a look again. Which one of these ones now is our substitution reaction, meaning a reaction where a saturated molecule reacts to give us another saturated molecule. This molecule is saturated, is reacting to give us another saturated molecule. So this is a substitution reaction. Also, the same applies with F. It's a substitution reaction. Right, let's go through the questions now and see if we have not done justice to them. Right, write down the type of reaction represented by A. we have seen that A is a reaction of an unsaturated molecule. So 4.1.1, A is addition. A is addition, right? 4.1.2, these are easy marks. D is the opposite of addition, so it means it is elimination, right? 4.1.3, these are easy marks, guys. F is a reaction where this one is a saturated molecule is reacting to give us another saturated molecule. So obviously that one is substitution reaction. That is substitution reaction, right? Before I go further, I just want to bring to your attention that alcohols, this is what is going to be tested. Alcohols, you should know that alcohols, they always need acids for them to go elimination or substitution. Fine? So elimination is a very difficult reaction to occur. So it needs very strong acids. So elimination needs H2SO4. Substitution is a relatively easy task for us to perform. So for substitution, we want acids that are strong but relatively not that strong, like hydrogen bromide, like hydrogen chloride, that is HCl, our hydrochloric acid, right? These are the most common ones, right? For haloalkanes, like this one is a haloalkane. Haloalkanes, they need strong bases for them to undergo either elimination or substitution. But what it differs now, for elimination, the base should be concentrated. For substitution, the base should be aqueous, that is dilute. Right. This concentrated sodium hydroxide will result in elimination. Dilute sodium hydroxide will result in substitution. Right. Now, let's have a look on the next question. Name or formula of the catalyst needed for reaction A. This one is an easy one. We should know that the catalyst is an easy one that is always known. That is a platinum catalyst. That is name or formula. So you can write using the formula. Then 4.2.2. Name or formula of the inorganic reagent needed for reaction B. Reaction B, let's have a look. This is reaction B. Reaction B is an elimination reaction, which is the reverse of addition. So we have said it earlier on. For alcohols to undergo elimination, they need what? Sulfuric acid. So now, name or formula of the inorganic reagent needed for reaction B, which is elimination. That is our sulfuric acid. Right. Then 4.2.3. Type of addition reaction. For us to move from here going there, it means we have added water. So the addition of water, that is called hydration. Type of addition reaction represented by C. That is okay, the question that we have done. Now let's move on to 4.24. IUPAC name of compound X. Okay, fine. This one, let me leave it so that I just wanted to concentrate or focus more on the easy questions which one can score. Though the IUPAC naming of compound X is easy, because if you are in a position to identify all the families, then it becomes easy for you to still answer 4.2.4, right? Let's have another part of the question, which is 4.3. Use the structural formula to write down the balance equation for reaction B. Okay, fine. It's not that much challenging. It's just need to writing all the reactants and the products. Then you show them with their bonds. But nonetheless, let me move on something that I find to be relatively much easier. Both reactions D and E, which is D and E, take place in the presence of a strong base. We have discussed this earlier on. to say this reaction of D as well as E. E is a substitution reaction. D is an elimination. Right. So the two reactions, they all need a strong base. We have had an example of a strong base, which is sodium hydroxide. Right. State two conditions that will favor reaction D over reaction E. Right. The two conditions are so easy. The first condition is we should have concentrated sodium hydroxide. So the condition is this sodium hydroxide should be concentrated, right? The other condition too is reflux. Reflux is very strong heating, or you can just say heat. For argument's sake, and just to bring things for clarity for you guys, if the question was talking about substitution would the conditions for substitution conditions, it was going to be dilute sodium hydroxide. We are using the same base, which is sodium hydroxide. But what differs is the condition. This one is concentrated, now it's a dilute. Then our heat is not going to be very strong reflux. We are going to use mild heat. These are the conditions now that will lead. These are the conditions that is going to lead us to have substitution. And these are the conditions which lead to elimination. So we need to be very careful on these simple conditions. Right, let's move on. So far, with these easy marks from organic section, you have scored roughly 30 marks, which is awesome. Right, let's see how much is 30 marks out of 150, which is already 20%. Fine. There is also some easy marks on some other sections which are still coming. That is our part 2 of the presentation from electrochemistry and fertilizers. Thank you.